Welcome to EDU World Space.
Alright guys, we're doing problem 112, chapter 9 in Chemistry Central Science. So the energy level diagram in figure 9.6 shows that the sideways overlap of a pair of orbitals produces two molecular orbitals, one bonding and one antibonding. In ethylene, there's a pair of electrons in the bonding pi orbital between the two carbons. Absorption of a photon at purple wavelength can result in the HOMO-LUMO transition. What is the HOMO in ethylene? The HOMO in ethylene, that's going to be your pi orbital. Because remember, your HOMO is your highest occupied molecular orbital. Your LUMO and B, they want to know, oh, what's the LUMO? The LUMO is going to be your anti-pi orbital. So C, is the CC bond ethylene stronger or weaker in the excited state than in the ground state? Why? Well, if you take this electron, let's say you take this electron and you move it to your pi orbital. You move from your HOMO to your LUMO. Oh, if you have less electrons in your pi orbital, if you have less electrons in your pi orbital, that's going to weaken your bonds. And taking electrons in your pi orbital and putting your antibonding in your anti-pi orbital, which by definition makes your bonding less stable, weakens it further. So I would expect the CC bond in ethylene to be weaker in the excited state than the ground state. So part D, is the CC bond in ethylene easier to twist in the ground state or the excited state? That's going to be the excited state. So in the ground state, you have a double bond, and that's extremely rigid. It's very difficult to twist. In the excited state, you have one electron in your pi orbital, one electron in your anti-pi orbital. This means that the electron in your anti-pi orbital will cancel out the electron in your pi orbital. The effect that they're going to have, the strengthening effect in your pi orbital, will be canceled out by the weakening effect in your anti-pi orbital. So this will cause the ethylene to lose its single bond and lose its to break its double bond and become a single bond.